Today we are going to go over two things. We're going to learn about rotation, which is really a shame that Nafi's not here because she was the one who specifically asked about it. So we're going to go over rotation. So rotation in Grasshopper is a little bit different than what you would expect in Rhino. The other thing that we're going to go over is inclusion patterning. Or inclusion curves, or whatever you want to call it. I think there's another term for it in Grasshopper. I just forget it right now. So those are the two goals. We're going to start off by just doing simple geometry rotation, and then we're actually going to develop a pattern and then start to exclude bits of geometry based on whether or not it is inside or outside of that curve or volume, or whatever you want to call it or use. So to start off, I just want to show you real quickly, just using a rectangle as, or rectangle or square, or whatever you want to use. The geometry doesn't matter, just don't use a circle, because then if you rotate a circle, you can't see it rotating. So let's go into curve and primitive, and I guess we could just drop in a rectangle. This rectangle is going to grow off of the origin point, so we can just drop in whatever numbers we want for it. I'll do 0, less than 10, less than 20. Feel free to deviate. Yes. Yes.
So, does it matter if I use the same scale for both, like X and Y?
No, it does not matter if you use the same slider for both. The result will be a square.
Oh, so you mean it's like if it's the same?
Yeah, because this one I can change one to make it a rectangle. But if I replace that with this, then it's always going to be a square. And that's fine. Yes?
When you, like the 10 or like whatever, you slide over to 20, that's just mean 20 feet? Or just...
Yeah, so if you recall from the first week, right, I said Grasshopper is unitless. So the numbers that you put in here don't have any inherent unit value, whether it's feet or inches or millimeters or miles. It borrows the magnitude of a unit from Rhino. So when this down here says feet, that's what it's going to use. That right there. Those are good questions. Okay, so we've got a rectangle. In this case, now I'm using a square. We have to drop in a rotator. So rotators are kind of complicated. When you go up to transform, and yes, it is a transform, it's under Euclidean. And you'll notice that there are 4 different types of rotate, and that's very important to understand. They have a planar rotate, which is this one, right? So it'll base the axis of rotation upon a reference plane. Then they have a simple rotate, which let's see, what is the different input for that? It's got the same description, but it asks you for a center point and a vector. I see. So this is a referential rotate from one position to another. And then we have rotate 3D, which is going to rotate it around an axial center point. And rotate axis is going to do something very similar. This version will do the same thing where it's going to go from one point to another. Angle, axis, right? So there are a couple of differences. Essentially, they all do sort of the same thing. But the thing to know about rotation is that you cannot rotate in 2 different planes at once. Every rotation is going to happen at one particular time. In one particular plane, sorry. So here's what we're going to do. For simplicity's sake, I'm just going to use the centroid to show you very easily what rotate is going to look like if you just wanted to spin it like a top. So I'm going to go to surface analysis. I wonder if I could just do it with the rectangle. Yeah, doesn't need to actually be a surface. So plug that into the area node, and you'll get your centroid. So the type of rotate we're going to use under Euclidean is for simplicity's sake, I think we're just going to use the planar rotate. So the planar rotate is asking us for the base geometry, which obviously is going to be our square or rectangle. And it's going to ask us for the rotation angle in radians. So that's going to probably throw a few of you for a loop, but I'll show you how Grasshopper makes it really, really easy for you to convert to radians. And then the rotation plane, which at the same in the same manner can also just be a point. Points sort of have an inherent plane in many cases, so we'll basically just build it off of that. So the geometry, I'm going to plug in the rectangle or square. Notice how it's already starting to rotate, right? So now you see that it's kind of twisted 90 degrees around the origin to the side. Wow, that green is really hard to see up there. You sure you guys can see that?
Yeah.
Okay. All right. And so the plane is going to be the centroid now. But it disappeared because it happens to be exactly in the same position that it was before because I made a square. If I change that to a rectangle, it'll probably look a little different. There you go. Okay, so now I need to actually specify the angle, right? So what we want to do is set up a rotator that's going to go from 0 to anything in between 0 and 360, or 359, or whatever. 360 is fine. So 0 to 360, if I plug that in, it's going to give me something that's kind of unexpected. It starts to rotate, but then it jumps in some cases. Now, why do you think that is?
Not factoring in decimals?
Degrees. Yeah. So it's not counting it in degrees, it's taking this number and it's reading it as a radian. Without going into the math, I'll just show you graphically what the difference is between a radian and a degree, just by Googling it, I guess. So a degree is the angular distance from the center point to the perimeter, right? So it's just an angle, right? 1 degree. If it goes straight up, it's 90 degrees. Like this one right here is 60 degrees. But a radian is essentially a measure of distance around the perimeter. So that's the difference, is that it's reading it as a distance around the perimeter rather than an angular difference between the 0, which is from center point straight out to the right, all the way around to 360. So what we can do, though, without getting into the math of it, is go under the Math tab. Don't worry, you won't have to do math. You can just click on trig. And what this will do under degrees and radians here, you have the opportunity to change a numerical input to read as a radian value and transition to a degree, or vice versa, it will transition a degree input that you give it into radians. So here, if I click convert an angle specified in degrees to radians, all I have to do is plug that number in, and now my 86 degrees is going to read as 1.5-ish. I plug that in, and that is an 86 degree rotation around the center point. It's under Math Trig. So I'll highlight this one so you can see it a little better. Radians. Because what we're giving it is what we want to give it is the degree number. We need to feed into rotate a radian. So we need to convert from degrees, which we're specifying, to radians, which it's requesting.
So already radiant, right?
No. So the slider could essentially be either. Just depends on what information you want to provide. So if you know the math and you know how to calculate radians instead of degrees, that's awesome. But it's easy to just take the conversion component and drop it in because the degrees are going to be based upon the radius of the circle, I believe, which can change.
Okay, so
Yeah.
the radian is gonna give me a degree and the opposite.
It'll get just look at the input.
If I want it in degrees, so do I choose the degree or the radian?
It depends. Well, it depends on what this is asking for. So right now it's asking for a radian, but I want to give it degrees because I don't feel like doing the math.
Oh, so that thing is gonna be like transfer the
Right.
information.
Yeah. So the radians component will switch from, if you look on the left, the input side is degrees to our
I'm gonna use
radians.
it as a degree, but it's gonna transfer it as a radian.
Yes, it translates it into radians when you feed it in. Okay, so now if you look at it really closely, now there are no jumps. It starts off at 0, obviously, but you see it's going to be a very smooth transition now as I rotate all the way around to the 360 mark, which is back into its original position. So, what questions do you have?
We have to rotate it using radians?
For this one, yeah. Yeah.
Even if the shape is not circular?
Yes. Okay.
Can we see it with one of the other rotates?
In a bit.
Okay.
We're going to work 2D for a while, and then we'll do some 3D ones. Then they'll come into play. Any other questions? Okay.